Hi everyone, in this lecture we will see the proof of associative property of linear convolution. So by associative property, convolution of result of convolution of x1 of n and x2 of n and x3 of n is equal to convolution of x1 of n and result of convolution of x2 of n and x3 of n. Fine. So this is what our LHS and this is what our RHS. Clear? So before going ahead and start about the proof, let's see few things. Fine. So let y1 of n is equal to what? This convolution of x1 of n and x2 of n. So this is our equation number 1. Fine. So what I am going to do here is replace this n by p in equation 1. So this equation will become what? y1 of p is equal to x1 of p, means convolution of x1 of p and x2 of p. Am I right? Now this is equal to what? Summation of x1 of m, right, into x2 of p minus m, where the limit of m ranges from minus infinity to plus infinity. Assume this is what? Equation number 2. Clear? Now do the same for this part. So now let y2 of n is equal to what? x2 of n, convolution of x2 of n and x3 of n. So here this will be equal to what? Basically this will be equal to, assume the dummy variable I am taking here is q, right? M is already occupied here, so we can take q. So it will be equal to what? Summation of x2 of q into x3 of n minus q, where the limit of q ranges from minus infinity to plus infinity. Clear? This is clear? Okay, fine. Now we are going to delay this output y2 of n. So we have to calculate basically y2 of n minus m. So how we can calculate this? So this will be equal to what? Summation of, what is the limit? Q is equal to minus infinity to plus infinity. Now x2 of q into x3 of, right, x3 of n minus q, right? So it will become n minus q minus m. So n minus q minus m. Hope it is clear to you. Let's say this is what? Equation number 4. So whatever we have used like p, m and q, this all are what? Dummy variables, which is basically used for convolution operation, right? So hope this much is clear to you. Now let's start our proof basically. So let's start from LHS. So LHS is equal to what? This convolution of this and x3 of n. So we already know what is this, boss? We already know this is what? y1 of n. Clear? So this becomes what? Convolution of y1 of n and x3 of n. Clear? So from here, from this will be equal to what? Summation of y1 of p, okay, into x3 of n minus p. Clear? N minus p, where the limit of p ranges from minus infinity to plus infinity. Okay. Now we already know about this y1 of p. So what is y1 of p, boss? Equation number 2. Remember the equation number 2. So if you see here, this is y2, here see y1 of p equal to this. Okay. Now let's go and replace that. So this will become what? Summation, okay, limit is what? P is equal to minus infinity to plus infinity. Okay, and y1 of p is equal to what? Basically this is equal to summation, limit is what? M is equal to minus infinity to plus infinity, okay, x1 of m into x2 of p minus m and into this, so into x3 of n minus p. Clear? This much is clear? Fine. Now what we can do here, this is properly a function of m, right? So we can bring these things out, and here p and p is there, so we can write the same as what? Summation limit is equal to m is equal to minus infinity to plus infinity x1 of m, okay, into summation p is equal to minus infinity to plus infinity x2 of p minus m and x3 of n minus p. Okay, it is clear? Fine. Let's move further. So what was the last equation we just now calculated? So the equation is basically equal to what? Summation limit m is equal to minus infinity to plus infinity x1 of m, right, and summation p is equal to minus infinity to plus infinity x2 of p minus m into x3 of n minus p. Let's say this is equation number 5. Now what we have to do, let p minus m is equal to q. So if p minus m is equal to q, it means what, boss? So when the p is minus infinity, q is equal to p minus m, it means what? This will be equal to minus infinity minus m, which will give you what? Minus infinity. Now if p is equal to plus infinity, q is equal to what? P minus m. So plus infinity minus m will give you what? Basically plus infinity only. Remember, this limit changes, right? Now if p minus m is equal to q, so p is equal to what? Q plus m. Clear? So now what we are going to do, replace p minus m with q and replace p with q plus m in equation number 5. Okay, so let's move further and do this thing. So now LHS will be equal to what? Summation of first term, this, right, m is equal to minus infinity to plus infinity, okay, x1 of m. Now for this we are going to perform this activity. Okay, so this will be equal to what? Summation of, so x2 of p minus m we have to replace with q, so q into x3 of, so n minus p is there, right, and p you have to replace with q plus m, so it will become n minus q minus m. Am I right? And here what is the dummy variable? Here is q, so q ranges from what? Minus infinity to plus infinity, so minus infinity to plus infinity. Alright, hope it is clear to you. Now going further, what is this, boss? What is this? You remember y2 of n minus m we have calculated? First y2 of n minus m, see here, this one we have calculated this, right, y2 of n minus m, and this is equal to the same we got, right? So what you can do here, basically by equation number 4 we can replace this with what? So this becomes summation of x1 of m into this, we can replace with y2 of n minus m, right? Limit is what? M is equal to minus infinity to plus infinity, right? We replace this with this. So hope this much is clear to you. Now if you observe this, what is this, boss? Nothing. This is basically summation of, convolution of x1 of n and y2 of n, and we already know about y2 of n. So this will be what? This, and y2 of n is what? Basically convolution of x2 of n and x3 of n. This is equation number 7. Let's say 7. this is 6. And this is what basically, this is RHS, right? So we started from LHS, we got the RHS. So we proved the associative property of a linear convolution. So if you have any doubt in this, you can ask in the comment section. Thanks for watching.